Hey folks, today I want to talk to you about state management, and specifically two different state management frameworks, tools, libraries that we use, and their advantages and disadvantages. So when you get into React, you will almost definitely hear about Redux and how to use Redux for state management. Essentially, when you're new to React, the things that you're presented are things like use state, maybe context, but there are some disadvantages to that, which is that if you want to pass data down the tree, or if you want to access your data from completely separate components not in the same tree, it becomes weird to pass that around. You can't really use state for that very easily. You almost inevitably end up reading about Redux. And more specifically, in the past few years, Redux Toolkit, which gives you a bunch of additional tooling around Redux to make things a lot easier. They've brought in some additional libraries that people used to mash together with Redux, and they've created a nice structured way of putting them all together. And they've added some tooling around TypeScript to make it easy to have a nice typed state, so you know what you're accessing when you're dealing with your Redux state. Another one that I came across, a friend mentioned it to me, is Jotai. These two frameworks are very different. Redux basically has a structure where it's a single huge object, and that's your state. And you split your state into subtrees that are managed by reducers, and you can have reducers inside reducers. Redux Toolkit gives you this concept of slices, which kind of maps out in the same way, but it's a bit more structured. So you can't do slices in slices, for example. But yeah, so it's this big tree, and you are aware of the tree. Now with Jotai, they come at it from the opposite direction. Instead of having one huge object that you layer on top of, you work backwards from what they call atoms. So you work from the individual pieces of the state, and you might compose them to make bigger and bigger things if required. But they're basically coming at it from opposite directions. Yeah, so I'm going to walk you through a little sample app. It's available on GitHub, and it shows how to use Redux and how to use Jotai to do very similar things, and I'll walk you through some of the pros and cons. So let's get started here. So here you can see the app. We've got Jotai and Redux. If I click on this Redux page, you can see essentially some sort of landing page where you're gauging, I don't know, a customer's interest in your stuff, in your products, and depending on their interests, you show them more or fewer things. It's a weird, contrived example, but that's what I got. Now, for each of these things, you might want to have a state within the component. So for thing one, I want, I don't know, three, or thing, I want three of them in my cart, experience, app, whatever. I want one mountain, and I want 10 apples. And, oh, yep, stuck at 0 potatoes. So we'll talk about how we do things like that. You can bound things or have rules in how your data changes. Okay, so with Jotai, we've got the same example. There's one little thing you'll notice is a bit different here. And this it's not required, but it highlights one of the differences. So here I've got 3 apples and 2 potatoes. And if I go down to 2, and I go back up, you'll see these things reset to 0. If I go back to the Redux example, you can see those are still like that. And if I go down and back up, this state is still here. So digging into the code, here is the Redux example. So in this case, Redux requires us to do something like this. Whoops, Redux store. So you create a store. This is your big top level object. We've done some stuff here to make it play nice with TypeScript, because we do everything in TypeScript to help prevent error. Yeah, to make it easier to not screw things up by accident. Yeah, with Redux Toolkit, you'll use combine reducers and configure store. And these reducers, reducer is basically a function that takes the name of an action and a payload and alters the state. And specifically, you don't want to mutate the existing state, you return something new. Yeah, so let's take a look at a reducer. So you can see here, we start with this like top level reducer. Then you go deeper into it from there. So here, the way we used to organize things when we primarily used Redux Toolkit is we would have the root reducer, and then we'd have one in our sort of pages and another one in modules. And that's generally how we organize our apps. Is if they're web apps, they have pages, and modules can be reused in different places. Pages are not. And so we have this reducer, and then you go one level deeper. So here we have the slice for this page called Redux. So we've defined our state. So it will have content, which we're fetching from a GraphQL API. We'll have this thing called interest, which is this thing at the top. We have widget states. Our content that we get from the GraphQL API returns a bunch of widgets. That's these things: potato, thing, light, mountain, apple. They basically have a name and an ID, and we want to save information locally. We have to have we want a state for each widget to maintain these numbers. So to do that, we have content. All the content. Interest is that top one, and then widget states is an object where the key for each item is a number, which maps out to the ID of the widget, and then this thing called widget state, which is just the ID and the quantity. Our initial state is content is undefined, interest is 1, and we have no widgets, so it's just an empty object. Before Redux Toolkit, people used to use this library called Redux Thunk to manage asynchronous calls, and Redux Toolkit sort of integrates that nicely. So you can do create async thunk. You have to give it a name. Since the name for our slice is pages redux, we'll just call this pages redux get content, and so that is an action to fetch content. So now let's get into the slice itself. Each slice needs to have a name, which is how Redux Toolkit is going to name the different actions. We'll look at those in a sec. So it'll create under the hood basically something based off of this name and the name of these functions to figure out which action is being called and which chunk of the state needs to be modified based off of that action. So here we have our initial state, which we defined up here. And here we have the reducers, so technically an action is just a name for something that you're sending through. So set interest, but the function is called a reducer. So remember how I mentioned earlier that with Redux, you don't want to mutate the state so that you don't have to write these wild functions that sort of where you do a lot of object expansion and weird stuff that becomes very long so that you're not mutating the state. Redux Toolkit integrates a library called immer so that you can mutate the state, and it'll take care of making sure that the thing that you return is not the mutated state, but basically a new object based off of a diff of this object that you're mutating. So here we'll say state.interest, and I want the interest to be clamped between 1 and 5. So you would not be able to set it beyond 1 or 5. And yeah, basically we use a type based off of this payload action type, and we say that the payload will be a number. So action.payload is a number, and we set the state.interest to whatever that payload is and make sure it's between 1 and 5. Increase widget quantity does something similar. We have a number, we get the ID, which is the number of the widget. We check if we have that in our widget state's ID, like if we have an object for it. If not, we set it to, we create a new object at that key. So widget 1, when we increase, we'll have an ID of the ID and a quantity of 1. If not, if it does exist, then we check if it exists by doing this. If it does exist, then we set the current quantity to current plus 1. We do basically the same thing for decrease, except that we check that if there is a current value and that current value is smaller than or equal to 0, then we just return what's there. In theory, it should never go below 0 because of what we've said here. Here you'll see something a little weird, interesting. which is extra reducers. So to handle those async functions that we were talking about, like fetching content, when you create this async thunk, it then provides you with the object you get basically has these states that act as like actions. So fulfilled and error. Is that one fulfilled? I can't remember. There are a couple of ways to get actions out of this. So these can't easily just be shoved in here, and you can't manage them as like you can't just add async in here and create something. Won't work correctly, and you can read into why. But basically they provide this extra function, or this function called, or this key extra reducers, which takes a function which passes an object called builder. This is where you'll handle the different cases for what happens when your async function either fulfills or fails. So here builder.addCase get content fulfilled, and we add, this is essentially a reducer here. So this is equivalent to one of these. So we have the state, and then we have the action. Here, my action is type based off of this type, which this is why I love GraphQL. It's so easy to just have typed things automatically. So this auto-generated get SDK calls this a GraphQL query, which returns this get content query object. And so we can just use that type both in here and here. So this knows the correct types. Cool, so we get that. And if we look at the page now, let's take a look at this. So the first thing we do is upon loading the page, and this is mostly for an example, you might want to do this in get static props or get server-side props or whatever for next. But for the sake of this example, we're just going to do it in a use effect that runs once after the component is mounted. With Redux, what you have to do is you've got this dispatcher, so this dispatch function. And you have to say, hey, I'm going to dispatch this action called get content, which we get from actions here. So we exported actions, get content, and slice.actions. So basically, when you create a slice, these things will be turned into actions. And they'll be properly typed based off of this payload action. Basically, it's a function that you call, and the result gets passed to this dispatch function. You can see a little bit like why we've moved to mostly using Jotai is I feel like this is a lot of mental overhead to think about all of these different structures and how you keep track of things and how it's all loaded. Yeah. Okay, so first thing we do, dispatch actions, get content. And that will load the content into our state. Yeah, into our slice, the state managed by our slice. In here, how do we access it? So in my header, whoops. I guess as I've been messing around with the code, triggering some refreshes. Okay, so all of this is content that is being fetched from our GraphQL endpoint, as are these different widgets. So once you see this here, essentially that data has been properly loaded into the state here. I like to build wrapper hooks around stuff. I think creating an extra layer of abstraction within the context of, for example, a page or a module or something like that, even just a component, gives you the freedom to change things after the fact while still returning something appropriate. So if I needed to, I don't know, double check that, or maybe we could get content from two different places for whatever reason, or I want to modify this content somehow. Having this one hook called use content gives me that flexibility to abstract things, and keeping it isolated in this hook keeps things nicely organized, in my opinion. And then I don't need to have this kind of code rewritten over and over, which is something you do tend to see where a function will have use app selector, use app selector, use app selector, and I just find this easier to read instead. So yeah, we've got this use app selector. These hooks have made using Redux so much nicer than it was before, but it still is, in my opinion, a fair bit of overhead. So essentially you've got use app selector, which will take a function that takes the state as a parameter, the full state of your entire state for the entire app. And this is the thing this is like the two philosophies, how they differ a lot. With Redux, you always base everything off of the entire state and you dig down. So state.pages.redux.content. That's where I'm fetching my data. And I've got use interest. So here I want a different part of the state. So I'm getting state.pages.redux.interest. So now we've got the widgets. So the widgets, which we see here, work this way. There's a bunch of different ways to do this, but essentially we have use content, which includes the widgets. So content widget slice 0 to interest. So yeah, we got the interest here, same as we did in the header, but we limit the widgets based off of the interest. You could do this in a selector as well. So you could do a function like this that's use widgets, and then inside the selector you would get redux.content.widgets, and you could get the interest level and do your slice in here. And there may actually be advantages to doing. I won't say I know them off the top of my head. I think there is some memoization that happens in use app selector or use selector. So here we get our limited slice of widgets, and we pass in a widget object. And in here we have another dispatch where we can increase or decrease the widget quantity. And that basically will affect an object inside this widget states object by ID. It all gets a little bit, a little complicated. That's basically it. And then when you reduce the count, right? So I've got 3 apples and I reduce the count. I go back, I still have 3 apples. And that's because you've got this global state, and we created this widget states object, and nothing gets removed from the state. It's still there. So when we go back up, that state is still there. So Jotai, I think there's a lot less complexity here, and it's one of the things I really like about it. Less complexity, and in a sense, more flexibility. So we don't have a slice, we don't have the store, we don't have anything like that. Here, so the equivalent to our fetch content thunk in Redux, the way that I've started modeling these things with Jotai is to create a hook which does something a bit like this. Actually, it depends on the complexity of the app and the context. Sometimes I don't even bother with something like this, or we'll use like Apollo to manage GraphQL content. In this kind of simple use case, what I would say is, so in the same way that we want to store the content somewhere, what I've taken to doing with Jotai is, so I'll create a hook called use, and then that little chunk of the state that I want. So in this case, the content. And then we'll create an atom. So content atom. And then an atom in Jotai is a little bit like using use state, but you can use it from anywhere. So it's just a shareable use state call, basically. You have to define the structure of that state in a sense. So you define what it's going to be here by saying atom, and then the type, and then you have to plop a default value into it. So here I've said it can be get content query or undefined, and by default it's undefined. And then same as use state, here you have the value, here you have the setter, and instead of the default value that you would have in use state, you have the atom, which defines that and will have a default value here. So yeah, usually what I do is I'll create a hook called use content, for example, and I'll return content and set content. I use this object structure instead of the sort of tuple or list structure, because I like the ability to create other stuff based off of these I can add it in here and I can return more than one. So I can say, I don't know, increment something or decrement or whatever, but we'll get into that in a sec. So we've got this hook, and here we've got this other hook called use fetch content. In here we have set content, and we'll just fetch the content and we'll set the content. And now we can use this use content hook anywhere and access this content, which I find so nice and easy. Just my mental model, like the way I think about state, this just makes me super happy. That makes it really easy to reuse this content just anywhere I might need to. For example, in the header. So same call, use content, and here I've got the content. I could also call get set content from here. Don't need it here, but you have access to that. And so you can really treat it a little bit like set state and use state. But we have something that's a little bit more complicated. Okay, let's start with interest. So you'll see that use interest is a little different. And this is where Jotai can get a little funky. It's still really cool, and you don't have to do this in an atom. You could just add another function here, like set interest. They do recommend composing atoms like this, and I can see some value to it. Yeah, you can decide what works for you. Essentially, you can create these atoms that are essentially like reducers in Redux. So in here, you can get the state of another atom, and you can set the state of an atom. And you can do that in a couple different ways. But here you'll see we just pass and you get this is to get the state of an atom, set the state of an atom, and this is the value being passed, which is defined here. So it's a bit like that, the action that what's it called? Typed payload or something like that. Your payload action. So here you're basically providing a type for your payload. So yeah, here we'll do the same sort of clamping of the values, and we'll set the interest atom to that value. I really like this way of keeping these things just stuck together nicely. You could create a bunch of slices with Redux, but then I always find it confusing. Okay, how do I then organize them in these combined reducers? Or yeah, it just doesn't match my way of thinking. But yeah, essentially we have this use atom will give us the interest, use atom for the set interest atom, and then this is the sort of write function. In case that wasn't clear, an atom has either by default you just give it a value and it will give you a read and write function, or you can provide a value or a read function or a value and a write function. In this case, we just get the write function because that's all we've really provided here. And so we have interest and set interest. So yeah, that would be my way of doing things for something like this. And yeah, basically on change, we set the value. So we just call that set interest function. And yeah, now things get a little funky. So I still like this way of thinking, but it does get a little weird. So if we look at our widgets, we saw that with Redux, we basically just set the value of an object within an object identified by its key to update the count for a given widget, the quantity for a given widget. And here, what we've got instead is we've got use widget quantity. And so we've got the default atom. So we've got the same sort of structure as the interest. So we've got the base, we've got increase and decrease. I guess you could call them a bit like reducers. So they're these write atoms. I don't know why I used null instead of undefined here. But yeah, basically, these give us the increase and decrease functions. So we wrap that all up in one little use widget quantity hook where we get all three of these things. So the quantity, a function to increase the quantity, and the function to decrease the quantity. You'll notice we don't have an ID, whereas with the Redux example, we had to pass an ID to the increase and decrease functions. Yeah. So this is something that I find really powerful and interesting with Jotai, but it's also a little weird. So let's take a look at the component that uses this. So let's look at widget, actually. Yeah. So in here, in widgets, do the same sort of thing as we did in the other component for Redux. And then we'll pass in a widget. And inside here, whoops, got lost between them. I was a little confused. There's something missing there. So same thing, we get our slice, we iterate over our widgets. But now in here, I've mixed a couple things together here. One is you have to, Jotai provides these providers. Provides providers. So you'll notice that's very similar to the setup for Redux. For Redux in the app here. You have to have a provider, and that manages the store. It makes sure that the store is accessible throughout the app. With Jotai, by default, you don't need to do anything like that. You just start using your hooks and everything works. It still manages that sort of centrally under the hood, but you don't need to think about it, which is great. To do this kind of thing, you don't have to do it this way. You could probably simplify it. But this is something that I find really powerful in the way that Jotai works, which is that you can scope atoms to a specific component and its subtree. So right now, this is simple, but let's say you had I don't know, you had a dashboard with a reusable graph component, and each graph, the user should be able to configure each graph in specific ways, maybe change the maximum dates or maximum minimum dates and display different values and all of that sort of stuff. But you wanted that thing to be reusable, and each of those components had its own complex state, but because it's a really complex component, you need to pass that down the tree in different ways. Essentially, what you would traditionally do without something like Jotai or Redux is you would maybe use context like this, and you would use state, and you would combine context with use state to update things in the context and pass that around. Jotai makes it a lot easier in that you just define your atoms as usual. It's not this weird mix of use state and context, and I always found writing stuff like that really confusing and messy. So with Jotai, you just provide provider. If you're not using TypeScript, you don't need to do this stuff. This is basically just so that we have proper typing, but essentially you have to provide initial values for any of the atoms that you'll be using under this tree. So with TypeScript, they somewhere in the documentation, they have this helper function, and basically it allows you to have an item, pass it a default value, and then you have this thing to get those default values, and then you pass those initial values along. And then inside here, so it can't be in the same component, which is why I have this inner structure. From in here, you can now do quantity, increase, decrease, and it all just affects this component. And yeah, so you don't need to think about any sort of list of components and updating their state. From here on in, anything under here, if you use quantity, increase, decrease, it'll just change it for this component. It has its own state for any of the atoms that were set here. So that's really cool, because if you have really complex components that you're passing, that need to manage their own state, you can keep them really nicely self-contained, right? With Redux, you have to think about things globally, but here I could just write this widget and have all of these hooks just nicely self-contained in one little thing. Say, this is the provider, it'll get some information in, and then we can change things just locally, and it doesn't affect everything else. However, that also means that when the component is unmounted, its state also is destroyed. So that's that. Which I think in most cases that I can think of, that's kind of what you want. If the component's gone, it's gone, and then when you remount it, you'll it'll have its sort of fresh state. You could also model what we've got with Redux in Jotai. So just an atom with a list or an object with keys, and have that at sort of a one level out. But I just think this is a really neat feature with Jotai. It also means that if you're building component libraries, you can keep these things really nicely isolated, and you know that Jotai is going to take care of managing that state for those component libraries and keep each component has its own state. Yeah, so that's kind of neat. The last little thing that I wanted to just throw in here is something that I find kind of convenient, which is using context to pass around props. So if you have a component that takes complex props, and you need to be able to access it from those props from different other components lower down the tree. This is just a nice pattern to do that, is you just take the prop, you create a context with those props, and you just say value is equal to props. And now you can access those props anywhere down the tree. So yeah, it's neat. It's what we were talking about, or what I was talking about earlier, that I was trying to get away from with Jotai, but specifically if it's just about passing props around, this is really valuable. Once you have setters, I find it gets really messy, and it's much nicer to use Jotai, which kind of just does that stuff under the hood for you. But yeah, this is just a nice way to do that, which I find particularly valuable with next pages. So if you have get static props, and you get a bunch of static content from the server, you can just use context to pass that around on a page without having to pass it from one component to another. So yeah, hopefully that was helpful. And yeah, let me know if you have any questions. If you have any questions about state management, if you have other libraries that you've tried that you think are better. I've also looked into Zustan, which is built by the same folks as Jotai. There's another one that's very similar to Jotai, also sort of atom-based, but I can't remember what it's called. Do you like Redux, like vanilla Redux instead of Redux Toolkit? Love to hear how you all manage your state and how and why you do that. Thanks for watching, and let us know if you want us to do any videos on other subjects in web development, mobile development. Leave them in the comments below, or hit us up on Discord. Go to gochewy.io/Discord and you'll head over in there, and we're happy to chat. Yeah, thanks for watching, and subscribe. Peace.